Brown rice occupies an interesting and somewhat controversial position in discussions about brain-healthy foods and metabolic support. When we examine it through the framework of ND plus metabolism and Alzheimer's disease, brown rice offers some benefits primarily through blood sugar stabilization, but there are also some genuine concerns that need to be discussed openly, particularly around arsenic contamination and individual metabolic responses to grain consumption. The primary benefit of brown rice relates to its effect on glucose metabolism. Unlike white rice, which has been stripped of its fiber-rich bran and nutrient-dense germ, brown rice is a whole grain that provides both fiber and B vitamins. The fiber content slows glucose absorption, leading to more stable blood sugar levels compared to refined grains. This matters for brain health because blood sugar instability causes oxidative stress and inflammation, both of which accelerate ND plus consumption by activating stress response enzymes. Brown rice also provides B vitamins including thiamine, niacin, and B6, though the amounts are modest. These vitamins support NAD+ synthesis and the broader metabolic machinery of energy production. The magnesium content supports mitochondrial function and hundreds of enzymatic reactions involved in metabolism. However, let's discuss the elephant in the room: arsenic contamination. Rice accumulates arsenic from soil and water more efficiently than most other crops because of how it's grown. Flooded rice paddies create conditions that make arsenic more available for plant uptake. Brown rice contains more arsenic than white rice because arsenic concentrates in the bran layer that gets removed to make white rice. This is deeply ironic. The part of the rice that contains the beneficial nutrients also contains the toxic contaminant. Chronic arsenic exposure is associated with cardiovascular disease, diabetes, and neurotoxicity. We're talking about eating brown rice specifically to protect brain health while potentially exposing ourselves to a neurotoxin. The levels vary depending on where the rice is grown. Rice from certain regions, particularly parts of Arkansas and Texas, tends to have higher arsenic levels than rice from California or imported basmati rice. For people eating brown rice daily, particularly as a dietary staple, arsenic exposure could become significant. The FDA has acknowledged this issue, but hasn't established strict limits for arsenic in rice products. Rinsing rice thoroughly and cooking it in excess water that's then drained can reduce arsenic content by about 50%, but most people don't do this because it's not part of standard rice cooking instructions. There's also the broader question of whether grains are appropriate for everyone. For people with insulin resistance, prediabetes, or type 2 diabetes, all of which are risk factors for Alzheimer's disease, even brown rice can cause problematic blood sugar responses. Some individuals simply don't handle carbohydrates well metabolically, and for them, emphasizing brown rice as a brain-healthy food might actually be counterproductive. The glycemic index of brown rice is lower than white rice, but still moderate, typically around 68. For someone with severe metabolic dysfunction, this could still trigger blood sugar spikes that cause inflammation and oxidative stress. Individual responses vary dramatically. Some people maintain stable blood sugar after eating brown rice, while others experience significant spikes. The phytic acid content in brown rice is substantial, binding to minerals like iron and zinc and reducing their absorption. For people at risk of mineral deficiencies, particularly vegetarians or people with absorption issues, the phytic acid in brown rice consumed regularly could contribute to deficiency problems. Soaking brown rice before cooking or fermenting it can reduce phytic acid, but again, most people don't do this. There's also the practical reality that brown rice takes much longer to cook than white rice, typically 45 to 50 minutes compared to 15 to 20 minutes. For busy people, this time barrier makes brown rice less practical as a regular staple. Pressure cookers or rice cookers can help, but not everyone has these appliances. The lectins in brown rice, while reduced by cooking, can cause digestive issues in sensitive individuals. People with leaky gut syndrome or autoimmune conditions often report that grains, even whole grains like brown rice, exacerbate their symptoms. Let's also mention that rice farming has significant environmental impacts, including methane emissions from flooded paddies and high water consumption. The sustainability of rice production, particularly given increasing water scarcity, is questionable. For people following low-carb or ketogenic diets for metabolic health or weight management, brown rice obviously doesn't fit. While these dietary approaches are controversial and may not be appropriate for everyone, for some individuals with severe insulin resistance, they produce better metabolic outcomes than moderate carbohydrate diets that include foods like brown rice. The realistic recommendation would be 1/2 to 1 cup of cooked brown rice, 2 to 3 times per week maximum, prepared by rinsing thoroughly and cooking in excess water to reduce arsenic. It should be one component of a varied diet, not a daily staple. For people with significant metabolic dysfunction, reducing or eliminating brown rice might actually be better than including it. In conclusion, brown rice offers modest support for stable blood sugar and provides some B vitamins that support NAD+ metabolism. However, arsenic contamination is a genuine concern that shouldn't be dismissed, and individual metabolic responses vary significantly. Brown rice can be part of a brain-healthy diet for some people when consumed thoughtfully and not as a daily staple, but it's not universally appropriate.